So if you look around right now, literally 90% of everything around you, your phone, your shoes, like even the chair you are sitting on spent weeks out on the open ocean.
Yeah, it's basically the invisible backbone of, modern existence.
Right. But global shipping is historically the world's oldest and most labor-intensive physical network. So how is it suddenly becoming like the most advanced digital brain on the planet?
Well, it is a really profound shift. I mean, we are witnessing this complete rewiring of global logistics. They're moving away from just brute physical force and moving into this era of hyper-predictive data.
Welcome to today's deep dive. Our mission today is to explore this radical digital transformation. And, to understand the future of how things actually get to you, we are looking at the ultimate testing ground.
Our biggest one.
Yeah, we are tearing apart the blueprint for the Port of Rotterdam. It's Europe's largest port, and they are basically racing toward a goal of being a fully automated, smart port by 2030.
And we have pulled together an incredibly diverse stack of sources to sort of make sense of all this. We've got a really detailed AI case study from Best Practice AI, plus some very revealing insights from an IBM interview with Rotterdam's program manager, that's Erwin Raidmaker.
Right.
We're also looking at a comparative productivity analysis from Freight Amigo.
And we are layering in some heavy academic firepower too, right? From the Rotterdam School of Management. Specifically, there's a thesis unpacking global data pipelines and some really vital research on the massive labor transitions happening on the docks.
Yeah, exactly. But, to understand why all of this data gathering is even necessary in the first place, you really have to look at the sheer physical scale of Rotterdam.
It's massive.
It is staggering. I mean, Rotterdam stretches out over 26 miles.
Wow.
Yeah. And it boasts these deep waters capable of handling, like, the largest vessels on Earth. We are talking about 140,000 vessels and 460 million tons of cargo moving through there every single year.
That's just hard to even visualize.
It really is.
Yeah.
And historically, that geographical advantage was basically all they needed to dominate. But the sources make one thing abundantly clear here, which is that a good location on a map is just no longer enough to stay competitive.
Because, you reach a physical limit, right? You can only dredge the water so deep, and you can only build the docks so wide.
Exactly.
So to keep growing and to manage this wildly complex global network, the port essentially had to recreate itself in the digital realm. And in that IBM interview we looked at, their strategy centers entirely on building what they call a digital twin.
Right, the digital twin. And this is basically the foundation for everything Rotterdam is attempting. It's a 100% accurate, real-time virtual replica of the entire physical port.
Like the whole thing.
The whole thing. They're tracking ship movements, the status of the infrastructure, local weather patterns, complex geographic data, and perhaps most crucially, the exact water depth across that entire 26-mile stretch at any given second.
Okay, so instead of just looking at, a static map, it's more like a Formula One team running a massive digital simulation.
Yeah, that's a great way to think about it.
Like, they are adjusting virtual variables to predict real-world performance before the car ever hits the track. But here, they are doing it with ocean tides and, massive cargo ships.
That is a perfect parallel. And the precision of this simulator allows for these operational gains that seem almost impossible when you first hear about them.
Yeah.
Because water depth in Rotterdam is highly dynamic, right?
Yeah.
They experience tides that shift the water level by 1 to 2 meters. So by feeding all of their infrastructure and meteorological data into the digital twin, they can predict the exact water depth in any specific berth up to 72 hours ahead of a ship's arrival.
72 hours out.
Yeah. And they factor in those tides and the exact dredging depth of the seafloor down to the centimeter.
Okay, let's unpack this for a second, because understanding why those centimeters matter was a massive aha moment for me. Because the port authorities have this flawless predictive data, a massive container vessel out on the ocean can safely decrease its safety margin. They reduce the keel clearance, which is, the distance between the very bottom of the ship and the seafloor, by just 30 centimeters.
Barely the length of a standard ruler.
Exactly, which sounds completely insignificant when you are talking about a vessel that weighs 100,000 tons. But that tiny 30-centimeter margin alters the ship's buoyancy and displacement profile just enough to allow that specific vessel to carry 20 additional cargo units on board.
Yeah, and then you multiply those 20 extra containers by the thousands of vessels coming into the port, and the compounding effects are just massive.
That's wild.
Saves a tremendous amount of money, it drastically increases the carrying efficiency of the fleet, and it significantly reduces the carbon pollution emitted per cargo unit. And all of that is just because a computer knew the precise depth of the water 3 days in advance.
But, knowing the exact water depth 3 days from now is completely useless if you don't know the exact minute the ship is actually going to arrive to take advantage of that tide.
Exactly.
Which sort of transitions us from mapping the present to actually predicting the future.
Right, because to make the digital twin truly actionable, it requires a predictive engine. So Rotterdam developed this application called Pronto, which serves as their standardized data exchange system.
Okay.
But the real magic behind Pronto is a self-learning artificial intelligence model. The data scientists at the Port Authority took 12,000 distinct items of historical maritime data and just fed them into this AI.
Wow, 12,000.
Yeah. And the system constantly cross-references variables, like the specific type of vessel, the cargo it's carrying, the exact route it's taking, its current sailing speed, and even historical behavioral data.
Like what?
Like how many times that exact ship has navigated into Rotterdam before.
Now, I actually have to push back here for a second. Because is predicting a ship's arrival really a problem that requires advanced machine learning?
You'd think not, right?
Yeah, I mean, we aren't talking about a delivery van navigating unpredictable city traffic and stoplights. It is a massive ship on a wide open ocean. You know its top speed, you know its coordinates. It feels like basic math.
It really seems like it should be simple, but the maritime environment is incredibly volatile. The sources actually break down exactly why a simple speed distance calculation completely fails.
Okay.
You are dealing with severe, unpredictable weather systems across different oceans that force sudden course corrections.
Yeah.
You have shifting last-minute priorities dictated by the shipping conglomerates. But honestly, the biggest variable is terminal congestion.
Ah, the butterfly effect of global logistics.
Exactly that. Just imagine a vessel arriving at Rotterdam from New York perfectly on time. But the massive crane assigned to unload it isn't ready.
Why wouldn't it be ready?
Because the previous ship currently sitting at that dock was delayed by a typhoon in the South China Sea 2 weeks ago.
Oh, wow.
Yeah, so that single delay cascades through the entire port, throwing every subsequent schedule into total chaos.
Okay, so the AI isn't just looking at the one ship. It's looking at the entire global board to predict those cascading delays.
What's fascinating here is the results are just remarkable. By analyzing all of those intersecting variables, the Pronto AI now predicts berthing times with a 20-minute window of precision.
20 minutes?
Yeah. Think about the scale of that. A ship is traveling for a month across the globe, and they know its arrival down to a 20-minute window.
That's insane.
This system has successfully reduced overall vessel waiting times in the port by 20%, and their long-term goal pushes the boundary even further. They are training the AI to predict a vessel's entire route, involving multiple ports of call, a full 30 days in advance.
Getting the ship to the dock precisely on time is, it's an incredible feat of software, but once it arrives, you hit a very hard physical reality.
Right, the boxes.
Yeah, software can't unload a ship. Physical machines still have to lift and transport millions of tons of steel boxes. And this is where the digital brain starts controlling the physical world. Because Rotterdam is replacing human hands with robotics at an astonishing scale.
Yeah, the comparative analysis from Freight Amigo gives us a very clear picture of this transition. They benchmarked Rotterdam's highly automated terminals, specifically the APMT MVII and RWG terminals, against traditional human-operated ports like Oakland in the United States.
Okay, and what's the difference?
Well, Rotterdam relies heavily on automated guided vehicles, or AGVs, and these really complex software-controlled stacking cranes. These robotic systems operate 24 hours a day, 7 days a week.
With no breaks?
Right, utilizing zero-touch container handling and generating 0% CO2 emissions.
Wait, what does that actually look like in terms of numbers? Because, highly automated can sometimes just be a buzzword for, like, a few shiny new tractors.
No, the productivity metrics projected for 2025 are stark. A single automated crane in Rotterdam is projected to handle 122,000 TEUs annually.
And TEUs, that's the 20-foot equivalent units, right? The standard measurement for a shipping container.
Exactly. So 122,000 TEUs. Now, if you compare that to a traditional crane in Oakland, which handles roughly 68,000 TEUs, the automated Rotterdam unit is 80% more productive.
80%?
Yeah. Rotterdam has achieved an overall terminal automation level of 95%, compared to Oakland, sitting at roughly 25%.
And what blew my mind in the research is that Rotterdam is already looking past those automated cranes to the next phase of physical infrastructure, which is fully autonomous ships.
Oh yeah, this is wild.
Which brings us to a fascinating project they call Container 42.
Which is a great nod to The Hitchhiker's Guide to the Galaxy, where 42 is the answer to the ultimate question of life, the universe, and everything.
Right. But, instead of a supercomputer answering philosophical questions, Container 42 is a hyper-smart, heavily sensor-equipped shipping container.
Yeah.
It has literally been physically traveling across the globe for 2 years, and its sole purpose is to collect what the port describes as invisible data.
Right, invisible data.
It is constantly recording microfluctuations and vibrations, the pitch and roll of the ships it rides on, ambient noise levels, humidity changes, and air pollution metrics both inside and outside the box.
And they are gathering this granular micro-level data to prepare the physical port infrastructure to receive fully autonomous ships.
Right.
We are already seeing vessels like the Finnish ferry Falco demonstrating fully autonomous navigation. And when you remove the human captain who can feel a strange vibration in the hull or hear a mechanical whine, you have to replace that human intuition with massive data sets.
To ensure the autonomous systems can react to physical anomalies safely, it is essentially a wearable fitness tracker but built for global logistics. It is constantly taking the vital signs of the entire supply chain as it moves through different climates and handling systems around the world.
That is a very accurate way to frame it. But here is the critical friction point in this entire master plan.
Okay.
The physical automation, the zero-touch robot cranes, and the localized AI like Pronto, they hit an absolute brick wall if the global paperwork remains stuck in the 19th century.
Oh, right. Because you can have an automated vehicle moving a box at lightning speed, but if the customs form required to clear that box is like a piece of paper sitting in a physical filing cabinet on the other side of town, that box does not move an inch.
Exactly. The speed of the physical object is entirely bottlenecked by the speed of the information tied to it.
Right.
Stefan Verhagen's thesis from the Rotterdam School of Management digs deeply into this exact problem. It's the immensely difficult task of integrating global commercial data with local customs enforcement.
How does that work right now?
Well, currently, Rotterdam manages its local ecosystem using Portbase, which is their National Port Community System, or PCS. And Portbase is highly effective at coordinating the local players, the local customs agents, the hauliers picking up the boxes, the forwarders.
But the thesis points out a massive blind spot with that.
Yeah, the visibility of Portbase essentially stops at the national border. It does not have access to the original source documents. It doesn't see the original commercial invoice generated by the factory in Asia where the goods were actually manufactured.
So to solve that lack of global visibility, the industry is trying to build massive data pipelines. We looked at the Global Trade Digitization Project, or GTD, which is a blockchain-based data pipeline built in partnership by IBM and Maersk.
Right.
There's also a similar platform called Deliver, developed by Samsung SDS and ABN AMRO. These blockchain pipelines are designed to stretch across the entire globe, providing end-to-end visibility. But, my immediate question when reading about these parallel systems was, why bother combining a local port system with a global blockchain?
It seems redundant at first.
Yeah, why not just build one giant global app like GTD that manages everything from the factory floor to the local truck driver and just scrap the local port systems entirely?
If we connect this to the bigger picture of how supply chains actually function on the ground, a single monolithic global app falls apart almost instantly.
Really?
Local ports are incredibly idiosyncratic. They have highly nuanced, location-specific regulations, complex local gate procedures, and strict national safety protocols.
Ah, okay.
A global blockchain architecture developed in a boardroom in New York or Copenhagen simply cannot micromanage the specific substacking rules for, say, a local river barge pulling into a single specialized terminal in Rotterdam.
Right. So the global system knows what is inside the box, but it doesn't know which physical gate the local truck driver needs to use on a Tuesday afternoon.
That is the exact disconnect. So Verhagen's thesis highlights the absolute necessity of synergy between the two systems. The GTD data pipeline provides the macro end-to-end visibility. It enables a mechanism called piggybacking.
Piggybacking.
Yeah, this means taking the original commercial source data, like the exact invoice and packing list from the Asian factory, and permanently attaching it to the digital identity of the container on the blockchain.
So the data travels with the physical box.
Exactly. And when that container approaches Europe, customs authorities don't have to wait to physically inspect it. They use what is called system-based control.
Which means?
Because the data on the blockchain is immutable and verified at the source, customs officials can verify the digital data flow itself, rather than stopping and opening the physical container. They clear the goods digitally while the ship is still miles out at sea.
Oh, that's smart.
Meanwhile, Portbase acts as the vital national landing place. It catches that globally verified data and translates it into the complex mechanical reality of the local port, telling the automated crane exactly where to put it and telling the local truck driver exactly when to pick it up.
It's like a flawless handshake between the global macro data and the local micro machinery.
Truly.
But this brings us to the most complex and unpredictable variable in this entire deep dive.
Oh, yeah. We have solved the water depth with a digital twin. We have solved the scheduling with AI. We have solved the heavy lifting with robot cranes. And we have solved the paperwork with blockchain data pipelines.
Right.
But stripping out all of that friction leaves one massive reality hanging in the balance, and that is the human workforce.
Yeah, technology of this magnitude does not exist in a vacuum. It interacts directly with human livelihoods, communities, and centuries-old labor structures.
Yeah.
The research from Jose Luis Gallegos at the Rotterdam School of Management tackles this head-on, focusing on the sheer scale of the disruption and the mechanics of inclusive labor transitions.
What are the numbers looking like?
The data currently shows that roughly 27% of global dock work is automated. But that figure is projected to skyrocket to an astonishing 85% by 2040.
An 85% automation rate is an absolute cliff. It fundamentally erases the traditional concept of what a dock worker is. The displacement is unavoidable, and the sources impartially detail two very distinct structural approaches to managing a transition of this severity.
Okay.
In the United States, particularly looking at the ports in Oakland and along the West Coast, automation faces strict, organized hurdles. The International Longshore and Warehouse Union, the ILWU, views this transition through the lens of protecting their members from potential 40 to 50% job cuts.
Right.
Their primary mechanism for managing this is utilizing hard contract clauses to actively block, limit, or significantly delay the production
And then you contrast that with the environment in Rotterdam,
Rather than utilizing contracts to block machinery, they negotiate the terms of its integration. The heavy focus there is on mitigating immediate displacement and funding robust and skilled programs.
So retraining the workers.
Exactly. With the goal of transitioning manual laborers into the technicians who monitor and maintain digital equipment systems.
So what does this all mean? It tells us that working virtually training AI or deploying a is actually the truly difficult part of the and this tension we are seeing on the docks of both London and Rotterdam with the survival of the that is the exact blueprint every single it directly impacts the
The port is fundamentally a microcosm of the wider economy. The labor negotiations happening in these automated trains are a huge part of the conversations about logistics, manufacturing, and even white-collar data centers.
Okay, let's synthesize this. We started with a physical 26-mile stretch of water and to survive the crushing volume of modern consumption. We had to completely digitize this reality, creating a flawless simulation that leverages 30 centimeters of water to save lives. It gave that simulation a brain, an AI capable of navigating global chaos to predict arrivals down to 2040. It deployed a physical army of automated vehicles that moved 80% more cargo without emitting a single ounce of carbon. It connected local operations to global blockchain pipelines to instantly clear customs through system-based control. And underneath it all, it was actively navigating this incredibly package magically appears on your doorstep 2 days later, you will know that magic had absolutely nothing to do with it.
Nothing at all.
You will understand the invisible symphony of predictive operations, sensor-loaded containers, automated humans operating
And I want to leave you with one final thought. We have seen how Rotterdam uses this vast web of data to predict the flow of ships and manage the local docks. But if a port becomes a fully predictive, AI-driven entity that knows exactly what materials are moving around the globe 30 days in advance, could ports eventually evolve from mere transit hubs into global economic brains? If they can see the holistic flow of global consumption in real time, could the smart port of the future eventually start telling manufacturers what they need to produce and when, based purely on the predictive shipping flows passing through their digital gates?
Wow. Evolving from just moving the boxes to actively predicting and dictating what goes inside them, that completely flips the script on who controls the global economy. Thank you for joining us on this deep dive. Keep questioning the hidden systems that run the world. And remember, the next time you click that buy button, there is absolutely nothing simple about the waters bringing it to your door.